Are those hard?
Yeah, they are.
He's just talking to himself.
What are we doing? Okay. So we've got some decisions.
Yeah. He was or is?
So we have 2 more days together.
Yeah.
Well, not you.
Oh, I know that.
And so we're gonna do our test over power series and all this stuff. We're gonna do that Tuesday. That way, if you want to ask questions or do anything like last minute, you can on Monday. And then, as far as if you're a senior, here are various times that you can take the exam. So, like, you can just pick one of these. Thursday, May 13th at 10 or 12. Monday, May 17th at 10, 12, or 1. We can overlap those. And then Wednesday, May 19th, 10, 12, or 1. Hopefully, I'm guessing most of you will have it done by this time because graduation's the next day. I will also here in the next day or so post a video. I might just put it on YouTube because I'm not sure how long you guys will be able to access Google Classroom. I don't know how long your email address will work. And if you just get booted out of Google Classroom, like after May 20th, are they just going to kick you out of everything?
I feel like one until July for August. For April.
Is that you've been told that?
I think
July
so.
1st is the deactivation.
But I'm gonna post a video on the process that you need to go through with Wright State to get your credit transferred to whatever school you end up going to. There is a process, and it's quite lengthy. Like, there's a lot of steps in that process. You have to request an official transcript. You have to have that transcript sent to your university. Then you probably are going to have to follow up with your university to make sure that the transcript was sent and that the credits were awarded. If you go to a state school in Ohio, there's no question that you will get the credit will automatically transfer. And I would probably even go as far as saying if you go to any school in Ohio, the credits will probably transfer. If you go to state school, they will. And I'm saying if you go to any school, like private school, most likely they're going to transfer. If you go outside of Ohio, I'd say it's 70% of the time it will. And 30% of the time you'll have to do some fighting. If you have to fight, like if you go to a school and you want to transfer those credits and you have to fight for it, you need to fight for it if you want the credits transferred. I mean, if you want to retake the class, your entitlement. You're entitled to do that. But if you want the credits transferred, and you have to fight for it, then fight for it. Because if you fight for it, chances are you will win. Like it'll go through. A lot of times what will happen is the university, the mathematics department, or somebody at the university will ask for a syllabus of the course that you took. And then that's a simple email to me, hey bidder, I need a syllabus, and then I will send it to you. So yeah, just don't let it, don't let someone just say, oh no, you're not getting this, and just move on. You should get it if you want it. Now some schools just have a policy of saying no. Like, they don't take anything. So, like if you're going to Harvard, well, I'm sorry. Probably have to retake it. But, yeah.
So on Ohio State, we have to take like placement tests for like each thing. But do we still have to take a math placement test if we're gonna get credits for?
I don't know how how that all works. Like, I mean, theoretically, no, you don't, because you already have taken college courses.
Yeah.
I don't know what would happen if you don't take that test. Is that what you were going to ask?
Yeah.
I thought I heard you in my ear. I thought I heard you say that. Like, I don't know what would happen if you don't take that test. Like, is it going to get flagged and then somebody's going to start tracking you down and be like, you gotta take this? Like, I don't know.
Yeah.
I mean, in the end, the answer to your question is no.
Yeah.
You might, I mean, that's something you're probably just going to have to ask the advisor that you get assigned. One of the things that you guys have to understand is, like, when you go to college, you get an advisor, right? But your advisor is, in many cases, your advisor is not someone who's really looking out for you. Like, your advisor is someone, like, advising undergraduate students is oftentimes assigned to professors as a duty, as university service. Like, when professors are working, they have 3 areas that they have to focus on: teaching, publishing, and service. And advising students, undergraduate students, is a service that they have to do. And sometimes it's sort of one of those things that, like, they're not real passionate about, and they're just kind of like, whatever. Go here, read the book, or check online, figure it out yourself. And other times you might get somebody who's really good at it and passionate about it, and they want to help out the undergraduate students as much as possible. So you just kind of have to figure that out when you meet them. But yeah, so in the long run, no, but you might end up taking it just to shut somebody up. Yeah.
Similar question. I can't remember if you've already answered this. I know that you said, like, when we have to credit the transfer credits by, but I don't really remember when it was. And Ohio State says do your orientation as much as possible, but I'm pretty sure we schedule classes right after orientation or during.
During.
Yeah, during.
Yeah.
And mine's in June, so like, how early are we?
So I will tell you that you should be able to transfer your credits to wherever probably within 2 weeks after graduation. Because I will have your grade, I'll have your exams graded pretty quickly, and I'll have your final grades computed pretty quickly. And it should go right into the system at Wright State. So once your grades are posted at Wright State, it's probably only a couple of days for that to turn over, for the credits to hook up, and then you can request the transcript. You already have a credit, a course for Calc1. That's already there. So, if you requested a transcript right now, it's already going to show Calc1 on it. So when is your orientation in June? Second or third week?
Yeah.
Yeah, you might be okay. If you don't have it yet, you just need to make sure you say, I have credit from Calc1 from Wright State, Calc1 and Calc2. And this is getting more and more common, I think, at schools like Ohio State, so I think they're getting better at dealing with that. But I would say by the third week of June, you probably get it. The transcripts are sent electronically, so it's, it very well could be that when you show up to orientation and you've already done the request, like, they're going to open up the computer, put your name in there, and then it's already going to be there. So in the old days, it was like, somebody licked an envelope and stuck it in the mail and did all that. That's like when I was doing it.
You said we should probably retake Calc2, right? Or no?
I didn't say
so.
I swear someone
was-
said that.
Yeah, McManus said that? Yeah, McManus said that because of his own kid. I can attest to that. Like, DJ struggled in Calc, but, I think that's really an individual thing, I think you all have the knowledge base, and if you got an A or a B in here, you have the knowledge base to be successful in the next course. You know, it's going to be a matter of how hard you want to work, and you know, if you're willing to put in the effort. Like, but that's going to be the case no matter what class you take. I mean, I can tell you, even if you retook Calc2, you're still going to work. It's going to be a lot of work for you. Like, even though you've already taken this class, you know, just because the expectation might be different. Like what your particular professor might choose to emphasize in their course might be different. And you're going to have to work on whatever it is to satisfy what he or she is trying to emphasize. But I mean, as far as like knowledge base, for you to be successful in Calc3, you definitely are there. I would say that the biggest issue that we have with Calc3 for anybody that's going into Calc3, directly from this class in this year, your probably biggest hole is going to be with parametric equations and polar coordinates. Like those two things, like we didn't really even touch parametrics at all this year in here. I mean, that's the, I don't want to say that too loud because this is being recorded. Broadcast all over the world. And that's a huge component of Calc3. And polar is also in polar coordinates and other in 3 dimensions as well. So, but could you figure that out and could you do it? I 100% believe that you would be fine if you want to put in the work. But many of you, like, Calc 1 and 2 is more than you're going to need. Like, it's more than you will need. You won't really need Calc 2, anything beyond Calc 2, unless you are majoring in a physical science or engineering or math. So if you're majoring in physics, chemistry, or engineering or math, those are really the only majors that are going to require Calc 3. Like even biology most of the time doesn't require it. So if you're majoring in like business, well, you didn't even need Calc 2. You just scored, 4 more credit hours for free. So yeah.
Julia was saying that at Ohio State, they schedule their classes like at orientation. Are most places like that? Do you know?
I mean, it's hard for me to say yes to that. I mean, I kind of feel like it's that way, but I don't know. I mean, I did when I went. I mean, I remember my orientation at Butler my freshman year. I scheduled classes.
So my
And that was
orientation
30 years ago.
is May 27th, which is like kind of soon. Do you think the Calc2 grade will be in there yet?
Your Calc2 grade will be there. The question is whether or not your transcript will be there. Like that, it's hard to know. But again, that's just one of those things that you can say, like, I took this, like, the transcript is there. It's just, it's not been posted yet.
And you can change your schedule right before, or even like, I'm sure you can.
Yeah, there's no, I mean, you can change your schedule like the day school starts. Like, yeah, I don't want to take this class. I did that lots of times. I walked in there the first day, I'm like, peace, I'm like, so, yeah, I mean, there's no, and you don't have to, I mean, I don't know if this is true anymore, but like, when I was in school, you didn't even have to go see your advisor to change your schedule. You just did it yourself. Like, I mean, there was no red tape that you had to go through. I don't know if that's still true, but. Other questions? I mean, I really wasn't planning on answering all these college questions, but this is good stuff, so. Yeah, so. All right, well. So what we have to do now, the last thing that we're going to do is we're going to learn how to build a series or a function using the formula. So we learned how to build a series from scratch, power series from scratch, which is an ugly process. It's tedious, and you're not going to have to do it for me, ever. We learned how to build a series, like build a new from an old. So we built a couple from scratch, and then we built new ones from that. In fact, I think the only two that we built from scratch were sine and e to the x. So like, and we built everything else that we know, all the other ones that we know from that. It's kind of interesting. Maybe we did 1 over 1 minus x. Just gave you that. But today we're going to just learn a formula on how to build a series. And then we're going to learn how, just a couple different ways on how we will use that formula. Okay. So as far as which, the other big issue that someone brought up yesterday, your Chromebooks. So someone's like, will we be able to use a calculator or our Chromebooks on the test? Your Chromebooks have to be turned in tomorrow if you're a senior. So like, I'll just make it so that you don't need Desmos on your test. So you can try. I'd rather you guys be able to turn that in. I don't want you holding off on that and making that annoying. If you want to use a calculator, you certainly could use a calculator. I don't care about that. I mean, Desmos, there's really not a lot of advantage other than just it looks pretty.
What about like all the colors?
You mean for the exam? Oh, shooters.
So we can just print it in on graduation.
I don't think that's gonna fly. You won't get your cap and gown.
They
They
said
said that
you
in
could
the-
turn it in act down
Oh, they did?
in the first email.
Okay, well, if they said that, then that's fine. Okay. You're talking about for the exam. I was just talking about the test. I forgot about the exam. What's that?
That's on this 12th, isn't it?
Yeah.
Just
kidding.
That's Monday.
In May, is that
Yeah.
the same?
Oh, man.
What's today?
Look at the exam.
I will problem solve that. Let me think of a solution to that.
No closer on the exam.
Well, I could just have everything just be set up, but yeah, let me think about that. Yeah, have a stupid exam. It's just all cancel that. The test would have been easy fix, but the exam is not an easy fix. I might just have a bunch of Chromebooks in my room that you can use. I just hate to make you drag. I hate to drag that out. Probably I'll get yelled at too. So, I could probably find some Chromebooks. The likelihood of all of you taking the exam at the exact same time isn't high. I guess, right? I mean, that's. How many are you want to take it Thursday, May, that day? Oh, I actually have a feeling what's going to happen. How are you going to take it on Monday? How are you taking it on Wednesday? Yeah, in the juniors, you guys that are juniors, you can take it even Saturday. Yeah. Let me figure out the crowd. That's, snap. I thought I solved that last night when I was home, but oh well. I was only thinking about the test. Okay, so our series formula. Shoot. Build a series with the formula. So the formula that I'm gonna give you is called the Taylor series formula, just named after some guy named Taylor. So we call it the Taylor series. For f, a function f, centered at x equals a. And this is what the formula is. And I'm just going to call it t of x. So yesterday, the people that were here yesterday, we went over this formula, and before we wrote it down, I was like, formula is actually pretty easy. And then Adele disagreed with me. Sarcastically, he was like, yeah, that's pretty easy. But then, after we sort of break it down, you'll see that it not really isn't too bad. You start looking at the structure. So, what do you notice about some things here? Like, the exponents in each one of the terms are the same as what? The factorial and the derivative. So, like, this is the first derivative, this is the second derivative, third derivative. Way we would call this is the nth derivative. And you just do this as far as you want. Okay? And then the factorials, technically speaking, you could say this is divided by 1 factorial here, and it would be okay. All right, so how does this work? You guys know, we're going to use one of the series that we know just to show you how it looks. So we know that e to the x, or we should know that e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and so forth, right? Now, I can really think of that as this. Whoops. Right, that's the same thing. Now, we built that from scratch, right? I think we built that series from scratch. Or I'm not, maybe I just told it to you. I can't remember. But where's this one centered? It's centered at 0. Okay? And technically speaking, I don't know why, but somebody named McLaurin, he had to get some credit or something because McLaurin said if A equals 0, I'm going to name it after myself. Okay? Like, you guys don't have to know for the test McLaurin series, but I created an assignment in Delta Math for you to, there's like 6 or 7 problems for you to do in Delta Math, and I think one of them references McLaurin. So it's just a Taylor with 0. Is that. Okay, so this is centered at 0, right? So let's look at, if we were to use this formula to build this series, how would we do it? Well, we need all of these values, so we need f of 0. If f of x is e to the x, what's f of 0? 1, right? There's f of 0, which is the first term. What's f prime of 0? Well, e to the x's derivative is e to the x, so f prime of 0 is 1. Okay? The next term is going to be f prime of 0, which is 1, times x minus 0, which is just x. So it's 1x. What's f triple prime of 0, or double prime of 0? 1 again. The next term is f double prime of 0 divided by 2 factorial. What's f double prime of 0? 1. divided by 2 factorial x squared. Okay? What's f triple prime of 0? 1. So the next term here was f triple prime of 0, 1, divided by 3 factorial x cubed. Okay? So that's how the formula works. Questions on it? Okay. So one way that we're going to use this is you might just build a series using that formula. Now, I'll be honest with you. If I asked you to build a series, say, for this function, if I made up this, just let's make up one for a second. F of x equals x cubed e to the x squared. Okay. Don't write that down, but just think for a second. If I asked you to build a series for that, I don't know that using that formula is the best way to go about doing that. Because using this formula to build a series for this function, you would have to calculate all those derivatives. And after the first one, it's really going to suck. Right? I mean, because to calculate the derivative of that function, you have to use the product rule. It would be kind of nasty. It would be easier to build the series for this just by building it off of e to the x, okay, and not the formula. Does that make sense? So sometimes it's not necessarily beneficial to build a series just using the formula, okay, unless the derivatives are just pretty simple to compute. Okay. Another way, though, that we might use this formula is I might give you a series. I might give you a series and then ask you about the function. Okay? So what would that look like? Well, it's, oh, this is not good. You see that? That messy blue? We can't have that. Oh. I mean, this is a travesty. I'm not using this pen anymore. So what if I gave you let's see. Ready? Let's say I gave you this. P of x equals 2 plus 7 x minus 3 to the first minus 6 x minus 3 squared plus 9 x minus 3 cubed. Okay, and I'm going to tell you that what I just wrote down, this right here, is the third degree Taylor series, sometimes called Taylor polynomial, by the way, for some function where's that center? At 3. Okay. So I'm telling you that this is where someone has used this formula and built a series, and that was the answer they got. Now I'm going to ask you questions about the function. Okay? It's like, can you decompose that into the pieces of the formula? So my first question for you would be, what's f of 3? What's f of 3? Well, according to the formula, f of 3 would be the first term. The term with no x in it. What is that? 2. Oh, beautiful. This is easy.
Okay. What's f double prime of 3?
Where is f double prime of 3 hidden?
That f double prime of 3 is hidden right there. Right? Because the term with x squared in it is the term that has f double prime of 3 involved. Right? Is f double prime of 3 negative 6? Okay, that's what everybody wants it to be. But it's not. Because negative 6 equals f double prime of 3 divided by 2 factorial. Right? We're using the formula backwards. The coefficient on x minus 3 squared, that coefficient is the second derivative at 3 divided by 2 factorial. So if the coefficient is negative 6, I'm going to set that equal to f double prime of 3 over 2 factorial. And what do I get for then f double prime of 3? You get negative 6 times 2 factorial, which I guess is negative 12. I'll just leave it like that for right now. Okay? Same idea. What's f triple prime at 3? What's that equal?
Is it 9? No. It's not 9. But 9's involved. 9's where it's buried.
We know that 9 is equal to f triple prime at 3 divided by 3 factorial. So f triple prime at 3 is 9 times 3 factorial, which Adele is telling me is 27. No, it's not. It's 54. Okay? So that's how we would use this formula backwards. Okay? All right, let's try this. I just wrote the formula again on this piece of paper. Megan, do you have a question? It looks like your hand is wanting to go up.
I know. Why did we skip 7 times x minus 3 like a second? Did we go straight to
We just did the first one.
Oh, I just, yeah.
Okay.
Yeah. I just skipped the first derivative. Yeah. I left that one out.
Never mind.
And I kind of intentionally did that just so you would, I wanted you to know that we were just not just going in order. I wanted you to zoom in on, oh, and if I want the second derivative term, I need to go to the term of the x squared. 2 extras? I've been teaching math for 24 years and I still can't. God's honest truth. 1, 2, 3, 4. Okay, so you ready to tackle this? Let's see if you can do the first question on your own. Well, let's read through all this first. Okay, so I'm giving you the formula. I just wrote it again. Okay? And then we call this a Taylor series or a polynomial. So now I'm saying, let's let f be some function. You don't know anything about them, but I'm giving you this information. I'm telling you f of 2 is negative 3, f prime of 2 is 5, f double prime of 2 is 3, f triple prime of 2 is negative 8. Okay? So part A. Use that formula to build the third degree Taylor polynomial for f about x equals 2. See if you can do that right now. I bet you can.
You're not using the formula backwards, you're using the formula forwards. Andy, that's you. You know how to do it, right? Oh, that was good.
Is there like a second?
Is someone calling you trying to sell you gutters? What the-
Okay, yeah, I'll let him know.
Is that for me?
No, it's for Zach. You have to call the paper and bring it to you.
Oh, it was for you? You should have just answered it.
And they said you got it earlier. And that she needs to send it.
What did you ask me, Becca?
Is there this thing at the second?
Yes.
What makes sense to them third degree? I don't get that.
What makes it third degree? Because I'm asking you for the third degree. What makes it third degree is it's going to have the power cubed. The second degree would be it would only go up to the power squared.
Oh, it's like how far it goes?
Yeah.
It doesn't go forever.
Well, in theory, it would go forever, but like the most that you could do with the information I've given you is the third.
Okay.
You follow me there? So, do we got it? So, part A would be -3 plus 5 plus 3/2. Is that what you guys got? You leave it like that, friends. Just leave it like that. Don't simplify that. Just leave it like that. So, what's the purpose of these Taylor polynomials or Taylor series? Okay, one purpose is that you can use them to approximate function values. Okay? So, like, I know from this information that f of 2 is -3. I know that. Right? And f of x is approximately going to be this. But not equal to, but approximately equal to. But then I could say, well, that means that f of, say, 1.5 is approximately equal to -3 plus 5 times 1.5 minus 2 plus 3/2 factorial times 1.5 minus 2 squared plus -8/3 factorial 1.5 minus 2 cubed. And if you did that math, that arithmetic, and simplified it and got a number, now I would do it on a calculator probably, right? That's an approximation of f of 1.5. Okay.
Could you just make it -0.5? Yeah.
Do you mean all of these?
Yeah.
Of course. Yeah. You just got to remember to put them up to the power. Yeah, totally. Okay. Now, I asked the folks that were here yesterday this, and I don't think I'm going to have time to get into this discussion with you all. We can talk about it tomorrow. Just the first two terms of that. What is that? You know this from yesterday. Figure it out. Do you remember? What is that right there? That -3 plus 5 times x minus 2. So I might not answer you today. So this is what you need to do. Is I made a Delta Math assignment. It has like 5 or 6 questions on it. So log into Delta Math and do that. Delta Math says it should take you 22 minutes.
That's what Delta Max is. Try that. Tomorrow we'll finish this. Then we'll talk about what's going to be on your test, what you need to know for your test. Everyone wants to know which of those series that you have to memorize. Still trying to make keep going back and forth. There's a part of me that thinks you should make you memorize all of them because there's not a lot else for the test. And that's an easy way to boost the grade.
What does that matter?
Like none of those,
Oh, I just so
none of those matter at all.
It matters because how scared I am for the exam depends on my quarter grade.
Or like how bad I can actually go in.
But honestly, let's say you have an 89.5. How do you do on the exam?
Oh, or not
It's not really going to matter. Like, your exam grade isn't going to have that much bearing on your overall grade, especially if your first quarter grade was like, you would have to really tank the exam for that to make a huge difference.
So
You just make me feel better in case I like actually.
It's a mental
do bad.
But what is
What if I actually
also?
failed the exam?
You're not going to fail the
Why
exam.
do they love people?
It's just
I don't
that
know.
It's just that
If you study for it, you're not going to fail.
Wait, I have a question about
You haven't failed anything all year. Why would you fail the exam?
So, what's 4 factorial divided by 3 factorial? What's 3 factorial divided by 2 factorial?
I don't know.
What's 2 factorial divided by 1 factorial? What's 1 factorial divided by 0 factorial? This has to equal 1 in order for that to keep going.
That just seems so weird in my head.
Yeah, I mean,
Because of the way we define the factorial, like it's just multiply down, like you're already at 0, so you can't multiply down. So it's just we're just defining 0 factorial to equal 1, and it actually suited our purposes very well because it worked here. You know, we made it work. We defined it out. It's like your parents named you Ellie. Like, we're just naming 0 factorial to equal 1, and it serves our purpose very well. So. To get rid of them?
No,
Oh.
you go to college next year. Or like, yeah.
I'm really upset. I mean, I've said this before, but like, I'm really bummed about this year because I really feel like I missed out on a fun opportunity with really good.
You'll get me next year.
I mean, I just heard so many times from Snyder and Cridge how much they liked their classes last year. And I'm not saying that you guys aren't great, but like it just, I think about what could have been. Like,
I will say this has probably been my most difficult class to take, but it's been pretty fun.
but I mean, like I don't feel like I got you guys at your best, and you certainly didn't. And like, I just think about like what could have been. I mean, even coming back, so you guys, since you guys are back.
Yeah, it's weird.
Like, I don't even know what you look like. I mean, I might see some of you next year without a mask on, and I hope I do see you without a mask on, and I'm gonna be like, now who are you again?
I mean, I didn't recognize her. I saw her, like, this was a month, 2 months ago. I saw her up in painting something. Did you have a mask on when I saw you that
Yes,
time?
I was
Oh.
playing with Spirit Loop and
Yeah, I didn't know who she was.
and he came over and he was like, "What are you doing this for?" I was like, "For fun." And he was like, "Oh, okay."
And then I emailed Mrs. Miller and was like, who was that kid that was painting?
Yeah, I was wondering why you were acting weird. I was like,
But see, like, I'm sitting looking at your face right now. If you came up to me in a year from now, like, I don't know your face.
"This is my face."
It's a nice face. Yeah. Would have been, right? Hi, Taylor.
Hi. Just getting a water bottle.
Oh, okay. And he's apparently turning into everyone's locker.
Do we need to bring our notebooks tomorrow? No, our notes and stuff like that?
I mean, yeah, I guess. We're gonna still do a little bit of stuff and clean up the ends.
And he goes, "Is the head of the household there?" And I was like, "I'm a student at school." He's like, "Oh, well, luckily they're not." Every time he's coming back, take him off the road. Yeah, she said it's cold. Yeah. I was just up to her for Annie answered call, and apparently the person had I didn't hear what you said. Annie answered call yesterday. Because I had her number. This was like freshman, like when I just got married. Literally. And she was like, "Are you taking me home today?" This is not me. You taking me home today? Are you taking me home today? Are you taking me home today? Yes. What's bigger? How are you doing better? Good. How are you?
How am I doing? Pretty good, I guess.
Good.
I'm a little upset. Guy used a different whiteboard marker, and see all that blue streaks all over the board up there. Very
You
upset.
tested out that day?
Yeah.
No, you were bad.
Yeah, Miss Mileship said they were good. She lied.
Well, she's a liar.
She's a big fat liar.
Maybe we're still on her whiteboard. You tried on that whiteboard? Maybe it's just your whiteboard.
No, I tried. These are the ones right here. Arteza. How do you say that? So today we are going to talk about how to build a series using the formula. I'm going to teach you this formula. We have our tests on Tuesday. I have to make figure out what you guys are going to do, you seniors, what you're going to do with your Chromebooks. Because I was thinking, oh, I can solve that problem with the Chromebook, easy, just the test on Tuesday, just make it to where they don't need their Chromebook. But the exams are a little tougher.
We can keep it and then turn it in cap and gown.
Yes, but many of you might pick up your cap and gown before you take yours.
When is cap and gown?
Cap and gown pickup is,
I think it's next Wednesday.
It's this fall.
yeah, it's next
Oh, yeah.
Wednesday.
Yeah.
So, and I have these options for our exam, like these various times: Thursday, May 13th at 10 and 12, Monday, May 17th at 10 and 12 and 1, and Wednesday, 10, 12 and 1. So, yeah, I got to figure out how to do that. I don't know if I can just get some spare Chromebooks to have in here.
Miss Jensen said we could talk to like the main office, because I told her I still needed it for each class. And she said to like talk to them and like tell me like I still need it.
Yeah, it's just such a small number. I think I might be able to like, wing it, not get you guys in trouble. But I don't, the last thing I want you to do is to be stressing out about that, so. We'll figure it out though. I'll figure it out probably this afternoon. Also, so we had a little bit of a discussion this morning in third period about you seniors who, when you go, you know, getting your credits transferred and whatnot. Okay, so in the next couple days, I will post a video that I made last year that walks you through the process on how to request an official transcript at Wright State. That's what you have to do. And then you have to have that official transcript electronically sent to whatever school you're attending. Like, you have to do that. If you don't do that, you will not get the credits for this class. Couple questions that came up, like, oh, I'm going to orientation in the end of May or the beginning of June. Like, and I'm supposed to schedule for my classes then. What do I do? Well, your grade should be posted and your transcript should be available to you probably pretty soon after graduation. Like, I'll have those exams graded and your grades calculated pretty quickly, just because I have lots of time built in my day once you guys leave. So, once graduation, I'd say give it a week or so after graduation, and then you probably would be able to go online and get that transcript request. Some people are asking about placement tests, like, oh, my, you know, such and such school is saying I need to take a placement test. Do I still have to do that? Well, probably not, because you've already placed into college level math. So you probably won't need to take a placement test, but that might involve you having to circumvent a process at whatever school you're going to. Like, and you just might have to just tell people over and over and over again, like, I already took Calc 1 and 2 from Wright State, and just say that. I took Calc 1 and 2 at Wright State for College Credit Plus. Most of you are probably in situations that you're going to schools that they're going to know how to deal with that. If you're going to a school in Ohio that is a state school, your credit is going, it has to transfer. It's legally, it has to transfer. If you're going to a private school in Ohio, I don't know of any private school in Ohio that doesn't accept the transfer credit. The only one that might not is Case Western. But is anybody going to Case Western that you know of? Anybody know anybody going to Case Western?
I think so.
I can't think of anything off the top of my head, but I certainly don't know what all 500 members of the senior class post high school plans are. So, yeah. And, you know, if you're going out of state, anybody in here going out of state? No, so don't even worry about that. So, Nicole, where are you going? Are you going to UC?
Oh,
Oh, you're going to UC. You're going to Ohio State?
Yeah.
Where are you going?
University of Dayton.
UD. Oh. Yeah, they take credit. What are you majoring in?
Information technology.
Oh. Okay. What's their math requirement for that program?
I think just algebra 2, as far as I'm aware.
No, not to get in. Like, for when you're at, do you have to take Calc 1 and 2?
I'm not too sure on that. I haven't looked at it.
Are you majoring in IT or computer science engineering?
Trying IT, but I'm also.
I'd say if you're going to go computer science engineering, you'll probably have to take the whole calc sequence. But, all right. Well, are you guys ready? Y'all ready for this? Oh, okay. You had a teddy bear when you were in kindergarten? Billy, how's it going? So the formula for building a series, my friends, we actually call it the Taylor formula, or a Taylor series, named after some dude named Taylor. Also called a Taylor polynomial. Now, I think this formula is actually really, really easy to remember. And I said that yesterday when I talked about this with the kids that were here. And then when I wrote it down, Abdel kind of scoffed at me. But then after we sort of broke it down, he's like, oh, yeah, that is kind of easy. So here's our formula. We'll say it's this. And you can go as far as you want. Oh, stupid, stupid, stupid. Thank you, thank you, thank you. Gosh, that's embarrassing. I should be fired. Yeah, make sure you fix that. Were you here yesterday? All right, so I said, yeah, this is easy to remember, and everybody looked at me like I was a crackhead. Why is this easy to remember? Well, what do you notice about the powers on the x minus a? What? They go up by 1. Very good. What else do we notice? They match the factorials. What else do they notice? And what else do they match? Yeah, they also match the derivatives, right? So, like, these are various derivatives. So, the term that has the power of 2 on it has the second derivative and 2 factorial. The term that has the power of 3 on it has the third derivative and 3 factorial. The term that has the power of n on it has the nth derivative and n factorial. Okay? So that's the Taylor series formula. If a equals 0, if the center is 0, apparently this Maclaurin guy, he had to get his name involved. It's called a Maclaurin series. A Maclaurin. Do you have to memorize Maclaurin? No, but it will show up in the Delta Math assignment that you have tonight. So when you see Maclaurin, it just means the center is 0.
Was like the Maclaurin series discovered first?
That I don't know, actually. I should know that. I don't know. I might look that up after class. It's a good question. So we're going to use this formula a couple different ways. We're going to use this formula to build a series, and we're also going to use this formula where I give you the formula, and we're going to deconstruct the formula and we're going to answer questions about the function. Okay? So first, we'll use it how to build a series. So we're going to actually build one of the series that we already know using this formula. Okay? One that we already know, just so you can see how it works. Okay? Yesterday, we did e to the x because Carrie picked it, didn't you? Okay, so today we're going to do a different one, just so you can see another one. Let's do the cosine of x. Okay? And we'll center it at x equals 0. Okay? Now, we already know the series for cosine of x centered at x equals 0. We already know it. But we're going to build it now using this formula, just to show you how the formula works. Okay? So let's write the 4th degree Taylor series. Now, I guess this would be a Maclaurin technically, wouldn't it? Because we're centered at x equals 0. For f. Okay, so ready? In order to do this, we got to calculate a bunch of derivatives. Okay? So here we go. What's f of 0? What's the cosine of 0? 1. Right? What's f prime of x? What's the derivative of cosine? Negative sine of x. So what's f prime of 0? 0. Right? What's f double prime of x? Negative cosine. What's f double prime of 0? Negative 1. What's f triple prime of x? Sine of x. What's f triple prime of 0? 0. And last but not least, what's the 4th derivative of f? Cosine. And what's the 4th derivative at 0? 1. Right? So now we're going to build a series. So the first term is f of 0, which is 1, plus f prime of 0, which is 0, times x minus 0 to the first, plus f double prime of 0, negative 1 over 2 factorial, x minus 0 squared, plus f triple prime of 0, 0, divided by 3 factorial, x minus 0 cubed, plus the 4th derivative at 0, 1, divided by 4 factorial, x minus 0 to the 4th. When we clean that up, what do we see? 1 minus 1 over 2 factorial, x squared, plus 1 over 4 factorial, x to the 4th. Does that look familiar? Isn't that our series that we wrote for cosine? Okay. So that's how to build it using the formula. Yeah.
Could there ever be other series that also would be a series for cosine? Could there be another series for cosine x?
Yeah, you could just change the center. Yeah, I mean, you could change. We could make the series for cosine of x centered at pi over 2. It would be essentially a series like this that's just been shifted, but yeah. I guess I don't know what you mean by completely different, but I think they would all be similar, if I'm understanding your question correctly. Oh, sorry, that's scratching on there. You guys don't like that. All right. So, what if we use this formula backwards? So now I'm going to say this. Here's another example of how we'll use this formula. I'm going to say that this okay, I'm going to write that down. And I'm going to tell you that this right here I'm telling you that that's the third degree Taylor series for some function. I'm not telling you what the function is. Okay? I'm just going to call it, I'm going to say the function's named f. And that series is the third degree Taylor series for f centered at where? Where's the center of that series? 3. Okay? Everybody got it? So now I'm going to ask you some questions about that. Are you ready? What's f of 3? What's f of 3? Where does that come from? If that's a Taylor series, then f of 3 is going to come from the first term. And what's the first term? 2. In fact, the Taylor formula says f of 3 is the first term. So f of 3 is 2. Okay? What's f prime of 3? Yeah? Be negative 7. Right? I'm going to skip one. What's f triple prime of 3? Where's f triple prime of 3 located? In which term? The fourth one. The one that has the power of 3 on it. Okay? Yeah, in this one it is the fourth one. Okay? F triple prime of 3 is buried in the term that has to the third power on it. So what's f triple prime of 3? 11? Or sorry, negative 11? So this is a little bit of a trick. Most people want to make it negative 11. Because, oh, these first two, I just picked off those numbers, right? However, if you look at the third degreed term in the formula, the coefficient is equal to what in the formula?
The nth derivative of a over n factorial.
So the third derivative divided by 3 factorial. So that means that 11 or negative 11 isn't f triple prime of 3. Negative 11 equals f triple prime of 3 divided by 3 factorial. So f triple prime of 3 is negative 11 times 3 factorial. I don't know what that is, but negative 11 times 6 or 66 again. Okay? Negative 66. Okay, so you just don't pick off this coefficient and say that's equal to f triple prime of 3. That coefficient is equal to f triple prime of 3 divided by 11, 3 factorial. All right, Now, using that same argument, what's f double prime of 3? How do we find that? That's what you should have written down. So f triple prime of 3, I'm sorry, f double prime of 3 is 5 times 2 factorial, I guess, which would be 10. Okay. If I just wrote that down, if I just looked at what we call the first degree Taylor polynomial, what would that be? Now, you were here yesterday. So you know this. Who wasn't here yesterday? Alex wasn't here, Nicole wasn't here, you wasn't here. You were here. You just told me you were here a second ago. Well, the fact that you remember this is like that is smart because you learned something yesterday and you remembered it. Like, isn't that what being smart is all about? So you are smart. What is that? Like, what I circled in pink there, or what I boxed in pink there, what is that with f, with regards to f, the function f? What is that? Do you know, Alex? Do you know, Nicole? None of them knew yesterday either. So, Gavin, you want to feel smart? What is it, Gavin? It's point slope, but specifically, what is this? How is this related to f? What do you mean it's point slope? Like, tell me more. So now I'm going to make you smart. What is it? That, what's in pink there, is the equation of the tangent line to this mysterious function, f, at x equals 3. Okay, now how do we know that? Okay, let's think about this for a second. Go back to this picture, which we've drawn a million times. Okay, there's a function f, right? Here's 3. How do I find the equation of that line? Well, I need a point and a slope. So isn't this point right here the point 3 comma f of 3? What's the slope of that line? It's f prime of 3, right? Everybody agree with that? So the equation of that line would be y minus f of 3 equals slope times x minus 3. And if you solve that for y, you're going to get f of 3 plus f prime of 3 times x minus 3. Which is what that is, right? So the first degree Taylor polynomial is the tangent line. Some people might even say that the first degree Taylor polynomial is a linear approximation for the function. The second degree Taylor polynomial would be a quadratic approximation for a function, because second degree is quadratic. The third degree Taylor polynomial would be the cubic approximation. Okay? So it's like If we zoom in really, really tight around this point, this function looks linear. If we zoom it in really, 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 really tight even more, we can make it look quadratic at that point. Or like a third degree polynomial at that point. Okay? Let's try this.
Is this an actual like function? I mean,
I just made it up.
okay.
Yeah, no.
So like, I'm trying to figure out what it was.
Yeah, I just made it up. I mean, there's probably lots of functions it could be, since I've only given you the third degree. So. Okay. So what I just handed to you, this piece of paper, the formula that we just wrote down earlier is written again. Really typed out nicely. Doesn't that look nice?
It does.
It says, we call this a Taylor series, and what happens if A equals 0? What's it called? Lovin? Okay, so here we go. Question 1 says, let f be a function with the following conditions or characteristics. F of 2 is -3, f prime of 2 is 5, f double prime of 2 is 3, f double prime, triple prime of 2 is -. So now I'm giving you the pieces. I'm giving you all the raw materials. You just have to use the formula to build the series. So try it. That's what part A is saying. Use the formula to build the series. I'm just giving you all the raw materials. You don't even have to find them. I'm just handing them to you. Okay, now be careful about abusing the equal sign here, because don't say f of x equals, because it's not equals unless we write all the terms. So you can use approximation, or just write the terms out of the polynomial. Oh, we got no Jimmy today.
No.
We got no Jimmy. Did you guys do it? Letter A? You feel pretty good about your answer? Like you say, I think I got this right, and I put $100 on it. I feel like you should have that confidence. Like, I mean, it's. So here we go. I think it's this. -3 plus 5 times x minus 2 to the 1 plus 3 over 2 factorial x minus 2 squared plus -8 over 3 factorial x minus 2 cubed. Don't you have? Don't you have, Aaron? So part B says use your previous answer to approximate f of 1.5. I just know f of 2 is 3, -3. Can I approximate f of 1.5? Sure. I can just take 1.5 and plug it in for x. Now, if I actually wanted a decimal for this, a decimal answer for this, what am I going to have to do? Oh, Mitter, you fool! There's something majorly wrong here that I wrote on the board. What's wrong? What? Yeah, I abused the equal sign. Like, this is equal sign abuse. Now, back to my original question. If I really wanted a decimal here, so I can say f of 1.5 is approximately equal to blah, 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 blah. What do I need to do there? Are you going to compute that by hand? God, no, you're going to put it into a calculator. All right. But you can just type that right into Desmos and it'll give you a nice, nicely packaged number. Okay? Let's keep going. You guys want to keep going? We didn't get this far last period. Sure. Okay, try part C. Let P of x be the fourth degree Taylor series for the function g of x, which is f of x squared plus 2. Build P of x. Make me a series for this new function. How are you going to do that? Is this the banjo technique? Banjo? Banjo? So is this how you would have started it? You're taking your series that we had for part A, which was the function f, and we're just plugging in x squared plus 2. Now let's do some cleanup here. Well, that's what, just hold your horses here, homie. If I do some cleanup here, what's this going to end up being? 5 times what? X squared plus 3 over 2 factorial. What's this going to end up being? X squared squared, which is x to the 4th. Oh, wait, I'm at the 4th degree. I'm done. So, in fact, I don't even need this last one, do I? I don't even have to write it. In fact, technically, I guess writing it would be wrong if I put P of x equals. So we don't even need that guy. Sweet. So interestingly enough, this new function that we just wrote for g is, and this polynomial here, it changed the center. Right? You see that? The center's changed now. What's the center of this guy? 0. Okay. So based off of what we see here, what's g of 0? G of 0 is -3. What's g prime of 0? What'd you say, Gary? 0. Why do you say that? It is 0, but why? If this is a Taylor series, that means this follows the formula, right? Where's G prime going to be buried? Where is it going to be located? With the term that has x to the first. Where's the term that has x to the first here? There isn't one. So G prime of 0 has to equal 0. What's G double prime of 0? Be careful, Gavin. You went the wrong direction. 5 equals G double prime of 0 divided by 2 factorial. So what's G prime double prime of 0 equal? 5 times 2 factorial. Can you answer the last question? This is going back to late September. Does the function g have a local max, a local min, or neither at x equals 0? The answer is staring right at you. The answer is right here. In order to determine local maxes and local mins, we talked about the first derivative test and the second derivative test. The first derivative test was when we saw that the derivative changed sign from positive to negative or negative to positive, we get a max or a min, right? Remember that? The second derivative test told us, okay, well, what if we can't determine if the first derivative changes sign, and we know the value of the second derivative, or the sign of the second derivative? At 0, the first derivative is 0, right? At 0, the second derivative is a positive 10, which means the first derivative is 0, and the second derivative is a positive 10. That means the function is concave up, which means at x equals 0, the function looks like this, which means that's a minimum. So it's a min at x equals 0 by the second derivative test. How about that? So there is an assignment in Delta Math. It's like 6 questions. Delta Math says it should take you 22 minutes. I don't know how accurate that is, but that's what I want you to do tonight before you go to the track meet. Well, 22 minutes. I mean, heck, you can knock that out during the time you're sitting here eating your 6 lunches.
I have a feeling it's gonna take a bit longer than that.
Yeah, I don't think it'll take much longer. Have a nice day. Yeah. Okay. So we know this is a Taylor series.
Let's just plug it
So we know it follows this formula, right? So this formula says that the coefficient on the term that has x squared in it, since it's x minus 0, the coefficient that has x squared in it, that coefficient equals after every time of 0 divided by 2 factorial. So 5 equals that derivative divided by 2 factorial. So to figure out what the derivative is, so like 5 equals that derivative divided by 2 factorial. So to solve that for that derivative, we just multiply by 2 factorial. The fourth derivative, it would be So the fourth, okay, yeah, that's actually a good question. I should have asked it. So the fourth derivative of g at 0 divided by 4 factorial equals 3 over 2 factorial. You see that? That actually would have been a really good question. Yeah, because do you see why that's way harder to see? Because the factor, you have factorials on both sides, so like you have to really understand it. You can't just say, oh, the factorial goes here. Yeah, whatever that simplifies to, right?